Okay, today we're going to talk about parametrics, which you should have done in pre-calculus. Parametrics relates, you always have an x equation and a y equation, and they're in terms of t, and typically when we say t, we're talking about time. So it asks us to sketch the curve represented by the parametric equation and write the corresponding rectangular equation. And let me also draw attention to the two links up here. This person does a better job than I do with the background. If you want to go back and watch them as well, or instead, either way. If you don't want to watch me, that's fine. You can watch the other guy. So what we're going to do first is we're going to make a little XY chart, but we're going to make a T XY chart. And I'm just going to pick some numbers. I picked these. Okay. And I'm going to fill them in. If t is negative 2, then x is going to be negative 8, and y is going to be negative 2 squared, which is 4, divided by 2 is 2. If t is negative 1, then x will be negative 1, y will be 1/2. If t is 0, x will be 0, y will be 0. If t is 1, x will be 1, y will be 1/2. If t is 2, x will be 8, y will be 2, and I just simply plug those in to the x and y equation. And now I'm going to graph not the t, but the x and the y. So negative 8, 2. These are basically coordinates here. 1, 2, 3, 4, 5, 6, 7, 8. I know I went off the graph, I'm sorry. Negative 1/2, 0, 0, 1/2, and 8 over here somewhere too. Now the thing with parametrics is they have a direction. Okay? I graphed it, the first point I graphed was here, and it went in this direction. So you put arrows on there. Okay, so sketch the curve, check. Write the corresponding rectangular equation. To write the rectangular equation, rectangular means in terms of x and y. So, can I maybe solve one of the equations for t and plug it into the other one where the t is? Sure. So x equals t cubed would be the easiest to solve because I can just take the cube root of both sides. So t equals the cube root of x. I'm going to then proceed to take this and put it where the t is. So y equals t, but t is the cube root of x squared over 2. So my equation is y equals, just to clean that up and make it prettier, x to the 2/3 over 2. Example 1. Alright, let's go on to example 2. We're going to do the same thing again. T, X, Y. This time I'm going to pick 0, 1, 4, and 9. The reason why I'm doing that is because I have to take the square root of these numbers. So, just make it easier. 0, and then I get negative 2, and then I get 1, negative 1, 2, 14, and 3, and 79. We're not going to graph those. Those are a little big. So 0, negative 2 is here. 1, negative 1 is here. 2, 14 is going to be way up here somewhere, and 3, 79. I think we can kind of see that it's going to go up that way. Okay. So now what we're going to do is we're going to go ahead and write the corresponding rectangular equation. If I solve this, I could square both sides. So x squared equals t. I'm going to fill it back in where the t is. So it would be y equals x squared squared minus 2. That's x to the 4th minus 2. And I'm going to go ahead and say that x has to be greater than or equal to 0. Why? Why would I do that? Well, because here, this x, is there anything that you can put in here that would give you a number that is negative? You can't put in any negative values. T has to be greater than or equal to 0. Therefore, x must be greater than or equal to 0. Because another reason we didn't choose any negative t's is, can we take the square root of negative 1? Well, no, that's going to be undefined. So we have to put a domain restriction on it. Here's example 2. The last one we're going to do for this video, so it doesn't get too long, is example 2 again. We're going to rename that example 3. It says sketch the curve represented by the parametric equation, da 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 da. We're doing the same thing again. Only this time I have sine and cosine, so I'm going to make life a little bit easier. And I'm going to pick some values off my unit circle. And I'm just picking my quadrantal values. In other words, I'm picking 0, 0, 1, negative 1, 0, 0, negative 1. That's 0, pi over 2, pi, 3 pi over 2. Okay, so if I pick 0, 2 cosine of t, and I'm just going to go ahead and give you these values. You can plug them in if you need to, but first I am running out of time here. Okay, and I'll just do one of them. If I plug in a 0, 2 times cosine of 0 is 1 times 2 is 2, and so on and so forth. And now I'm going to plot these points. 2, 0, 0, 4, 1, 2, 3, 4, negative 2, 0, 0, negative 4, 1, 2, 3, 4, and back to 2, 0. And it actually is going to start repeating because you're going to start going around and around your circle. So it is an ellipse with direction here. It's going to just continue around and around and around. Now to find the equation, anytime you have sines and cosines, we have to kind of go back to our trig identities. Sine squared plus cosine squared equals 1. That's a given, right? It holds true for everything. So if I can go back up here and solve these for cosine and sine, I can then plug them in to my equation. So if I just bring this down, x equals 2 cosine of t. Let me solve that for cosine. So cosine is going to equal x over 2, and then sine is going to equal y divided by 4. I'm going to plug these in here. Well, what's sine? Sine is y over 4 squared. Cosine is x over 2 squared equals 1. If I clean that up, that's y squared over 4 plus x squared over 4 equals 1, and that ends up being the equation of an ellipse. And we'll stop for this particular video.